Hello, my name is Diana Adams, and I'm happy to be back with more information about the cloud-native 5G core network transformation journey for CSPs. From a consumer's perspective, it's a great time to be alive, isn't it? The technology we carry in our hands has more than 100,000 times the processing power of the computer that landed a person on the moon in 1969. Add 5G to this technology we have in our hands, and it's a total game changer. For communication service providers, 5G brings a whole world of new opportunities. There's all kinds of new use cases like cloud gaming, live arena events, and sports broadcasting, just to name a few. But to get to the other side of these use cases, CSPs have to navigate a complex transformation journey. It's a whole technology shift that affects every aspect of business. It not only impacts the core architecture and cloud infrastructure layer, but it also affects business operations and the lifecycle management of the network. And then there's the most important part: the people. A successful transformation requires a mindset shift. Agility, flexibility, adaptability, and continuous learning are all critical. In this video, my goal is to break down some of the key aspects of this transformation in simple terms, and I'll be calling on my friends from Ericsson for help. Recently, Ericsson asked their customers who have gone through this transformation if they had any advice for CSPs who weren't as far along in the process yet. Marcelo Malizia shares those insights in this next clip.
What they point out is first that it's very important to have a platform, of course, to build your platform for cloud native. And this platform should not be looked at just from a technology point of view. It should be planned, and the transformation should be done hand in business and technology teams. They should be working together hand in hand, planning for the evolution of the network. There is, of course, different ways to get there. Some are starting the cloud native adoption with the 4G EPC, evolving to a cloud native platform. Others are starting with the new 5G core and offering 5G SA services. Of course, when you go for an overlay type of deployment, it gives a lot of flexibility or gives more space for the service provider to learn this new technology and adapt its processes and prepare the people to work with this platform without disrupting the 4G network. Device testing is an area that requires a lot of attention, and service providers should look at that from the beginning. But one very important thing that most of those our customers point out is that automation capabilities are really key. Looking into CI/CD and having that thought from the beginning. It should not be an afterthought. You should look at the beginning how to start implementing CI/CD into the operational into operations for this platform.
With all this complexity, it makes sense to use a dual mode 5G core integrated solution. And this brings me to a quick chat about hybrid cloud. Hybrid cloud brings CSP and hyperscale cloud infrastructure, public and private, under one umbrella. The three big hyperscalers are Amazon Web Services, Google Cloud, and Microsoft Azure. The most obvious example of an application using hybrid cloud is 5G core. There are many advantages to implementing a hybrid cloud strategy in a stepwise journey.
The hybrid cloud will then be based on the mobile telco network that is there today with our CSP private infrastructure, CNIS and NFVI. Also our 5G core application on top of that, and our orchestration suite for seamless automated orchestration. We see that the hyperscaler platforms will come in to complement that. And on the right side here, we see the elasticity. We can use the capacity of the cloud regions and expand into the public cloud and then go back.
Great job, Patrick. As Christer Baumann explains in this next clip, Ericsson breaks down the network transformation path into two stages. One is the cloud native transformation journey, and the other is the 5G core standalone architecture journey.
We have two major transformations. One is the 5G core standalone architecture and the other cloud native infrastructure. So all of those are being fine-tuned and hardened. The multi-vendor testing has been going quite well. Within Ericsson we do the full end-to-end verification with the devices, radio, 5G core and the surrounding elements, which has then helped us to do the multi-vendor testing quite efficient.
There are many different paths to a cloud-native dual-mode 5G core, and then 5G core scale. For example, SK Telecom was the first service provider in the world to go live with a 5G core from Ericsson on top of bare metal infrastructure. They had been on a virtualization journey for a while when they decided to do this. Another example, Ericsson supported BT in the UK with a modernization-driven approach to their transformation. They went straight from a legacy physical network to a cloud-native platform without going through that virtualization step beforehand. Vodafone, on the other hand, worked with Ericsson to take a 5G standalone-driven modernization approach. And then there's other companies like Telstra, Rogers, Singtel, TPG Telecom, and many others who have partnered with Ericsson and gone through their own unique transformation journeys. Now I'd like to take a minute to talk about two other important aspects of a dual-mode 5G core network. One is energy efficiency, and the other is signaling. As I've said before on Twitter, whenever somebody asks me about being an Ericsson ambassador, I always mention their focus on sustainability. They take their goal of net zero emissions seriously, and that includes reducing energy consumption in mobile core networks. First up is Victor Manuel Avila to talk about this.
In this proof point, we are going to describe the new mechanism we have in order to reduce the energy in the core, and especially on the user plane. Why? Because the user plane is the main consumer of the traffic growth that we will have in the next 4 years. So we have today some mechanisms to reduce energy that you can start to deploy now. For example, on the user plane, you can consolidate all the GILAN functions, optimizations, NAT, firewall within a single box. You can also use video shaping. Video optimization will reduce the consumption within the radio. You can also use the cloud native mechanism to scale in and scale out dynamically, so you can adjust the footprint to the needs that you have on your traffic. And finally, in this proof point, we are going to focus in two new mechanisms that we are bringing to the market, leveraging on the new capabilities that comes with the new processor generation.
Signaling is also an essential part of the 5G core. Why is it important? Because it simplifies the network architecture a lot. Plus, it provides overload protection and another layer of security. In this next clip, Timo Sturman explains Ericsson's signaling controller.
What is the reason? Why should you have a service communication proxy or signal controller in your network? First reason is that you simplify your network and you introduce an overload protection. The SCP doesn't optimize load balancing between all the network function, and that adds a great value to your network. The second aspect and driving factor is usually security. If you introduce roaming, then the ZEP, the Security Edge Protection Proxy, is a mandatory network function. The ZEP establishes an N32 connection between the home and the visited network, either through TLS or through pins. Into the ZEP we have integrated our unified signaling firewall, and with this we support cut 1, 2 and 3 checks according to the GSMA recommendations. Also, our unified signaling firewall can connect to our diameter signaling controller or IP-STP, and with this we ensure a cross-protocol security and firewalling, which is extremely useful. Last but not least, the service communication proxy simplifies the network architecture. You think about the large countries, and you might have divided your network into several regions, and each region then can be connected through an SCP with an optimized routing. This will extremely bring the complexity of your network down, and with this you save a lot of OPEX and money for your customers.
No matter where you are in your network transformation journey, you are not alone. Ericsson can help. If you are a communication service provider looking to transform to a 5G core or to take the next step in your 5G core journey, I encourage you to learn from others who have been through the experience. You can do that by clicking on the link in this post. As always, thank you for watching my video, and I'll see you again soon.